Okay, so let's start with the execution of Koch curve snowflake assignment. Previous sessions we already completed its execution, how it will execute output. We already saw it in previous session. So the smallest assignment from your all assignment, the code is so small but somewhat trickiest, that is Koch curve. What is Koch curve? It is a type of fractal actually. Let's see, you are having this line, a straight line. This straight line is getting divided into equal length. Assume that this all three sections are having equal length. So each line is getting divided into three equal parts. So each line is of 1/3. Koch curve fractal is a simple algorithm, recursive, which produces a snowflake from triangle. The concept behind this is to break a line into two while leaving 1/3 of the space between them, where we are going to fit two more lines forming an equilateral triangle without base. So this is the process which getting repeated to all the lines again and again, and we are going to call it as Koch. So after dividing this line into three equal parts, the central line is again getting divided into an equilateral triangle. So if say we are divided this line into three equal parts, and after that we are going to draw the central line into three equal parts, such a way that it will form an equilateral triangle without base. So base will not be there, and here we are having first line. The second line get divided into two equal lines such that it is going to form an equilateral triangle without base. The base is not here, but this length is equal to this length is equal to this length. So all these lines, three lines of equilateral triangle are same. So that is one iteration, and here we are having one finite line starting from this point to this point, and this finite line, which is one line, get converted into 1, 2, 3, 4 lines with first iteration of Koch curve. Again, in next step, what we are going to do, again each line is getting divided into three equal parts, and each line's central part is getting divided into this equilateral triangle without base. This line is also getting divided into three equal parts, and here also we are going to make this Koch curve, which is an equilateral triangle without base. This line also get divided into Koch curve with second iteration. This line also get divided into Koch curve with second iteration. So that 4 lines again get divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16 lines. So that is with third iteration. If you go repeating again and again for fourth iteration, fifth iteration and so on, again each line is getting divided into 3 equal parts and the center line will again get divided into that Koch curve. So like this you are going to form a snowflake, right? With first iteration you are going to get light divided into 3 equal parts, and again that their inner lines again get divided into 3 equal parts and making that Koch curve. So this is what the logic behind the Koch curve. And in our assignment we are going to take this inverted triangle with 3 equal lines, and with first iteration we are going to see this output, that each line will get divided into 3 equal parts. The center line is going to form the Koch curve effect without base. So this will get removed, this will get removed, this will get. Second iteration, again here each line is getting that spike of Koch curve for all this. Again with third iteration, at all lines again we are going to get that Koch curve. So that will form a snowflake kind of structure, which we are going to see in our assignment. So that is what we will see, the explanation of Koch curve. Let's start with the main function first. So what we are having in the main function, as we are having all the things in our first assignment, same kind of things we are having, that is glutenate, which initialize your graphics window. Display mode we are going to initialize. Window size is of 500 by 500. The position of the window is going to start from 0, 0. The name of the window which we are going to set in create window is Koch Snowflake by Marcus Young. Then we are having glue display function, and in that we are going to call my display function. Only one function here we are going to call. There is no mouse function, no keyboard function. Inside my display function we are going to call our Koch curve function, that is draw Koch function. First iteration, second iteration, third iteration and so on. And we are having one more function, that is draw Koch. So like this, main function, my display function and draw Koch. We are having 3 functions in this program. That's it. Lastly, glue to main loop we are going to have, and the GLN and GL flush we are having inside my display function itself, because there itself we are going to end it. So let's see my display function after this main function. So what we are having in my display function, we are having GL clear. First it will clear the output window, then GL begin and GL end. In this loop of graphics library, basic graphics primitive that we are going to use here is GL underscore lines. With the help of GL lines we are going to connect the vertex and we are going to get the output of Koch curve. So in this GL begin and GL end we will have this Koch curve. So let's see the first 3 calling function of Koch curve and its output. So I am uncommenting it. So first, whatever lines, the forehead color of the lines which we are going to draw, the color of that lines is 1.0, that is red. 1.0, 0.0 and 0.0. So it is going to draw that lines in red. Then we are going to call this draw Koch function 3 times, one for each side of the triangle, changing direction each time. So this is the first line. Whatever output we are going to draw, that inverted triangle, right? So inverted triangle, this is first line. Then we are having second line, and then we are having third line. So this starting point and end points are fixed, and depending on this, you are going to calculate this new point, which is inverted equilateral triangle, by using some cos and sine function, because as we know, these 2 points we can calculate this point. So we are having only start and end point. We are having only one point there. Based on that, we are going to calculate rest of the point, and we will iterate it. We will see that. So here, first we are going to call here draw Koch function with 3 parameters. The 3 parameters are, first parameter we are having to this draw Koch function is dir, the direction, then the length of that line, and next one we are having number of iteration. So for this, we are having the first line starting at direction 0.0, next is minus 120, another is with plus 120. So this is the angle direction which we are going to set to the lines, which are getting automatically calculated from the first point, that is 0.7, 0.5. This is the first point only, and based on this we are going to calculate rest of the point with the direction. So this is going to form your that 3 lines. Second parameter here we are going to use, that is length. The length of that particular line, each and every line is set to 0.5, so that it is visible within your window. And iteration we are going to set it to 1. So only one iteration, each and every line is getting divided into 3 equal parts. The center line is going to convert it into Koch curve kind of thing. So let's see the output of this. So here our program is Koch.c. Then output is, so that 3 lines according to the points we have set it, we are getting here first iteration of this equilateral triangle. The central part is getting converted into an equilateral triangle without base, right? So this is the first iteration. If we make it to 0, this iteration value to 0, what we are going to get? We are going to get a simple inverted equilateral triangle, right? Let's see this. We need to compile it again as we have made changes. And yes, so here the length is getting reduced, right? Because we are not going to make any iteration, and as you are not going to make any iterations, this other points will be calculated without that iteration, and based on that formula, cos and sine, whatever we applied in Koch curve, we are getting reduced sizes. So that is your original 0th iteration, simple line with equilateral triangle. So this is with 0th iteration. For next iteration, 2 iteration, we have to change this length from 0.5 to 0.15. If you don't change this length 0.5 to 0.15, we are not able to see the complete output because that values are getting calculated beyond your viewpoint. So we have to set this value to 0.15. So let's see this output with 2 iterations. So I'm commenting it. Now this is again GL color 3F, which is going to set with color that is green. And draw Koch, again we are having this side of the equilateral triangle that is starting with direction as previous, same 0, minus 120 and plus 120. Length is from 0.5 it is changed to 0.15 and iteration is 2, 2 and 2. Let's see the output of it. So again compilation is required. So that equilateral triangle, again this remaining side was getting converted into Koch curve. Again this side is of equilateral triangle without base is getting converted into this Koch curve. This side again getting converted into Koch curve. Again every side is getting converted into Koch curve. So it is nearer to the image of snowflakes. So that's why this combinedly going to form snowflake. So with this is the output with second iteration. And lastly, we are having output with 3 iterations. So here GL color 3F, now it is set to the last color that is blue. So after red green the output is blue. Again here value directions are same 0.0 minus 120.0 plus 120.0 and the length here we are going to set it to, again from 0.15 it was changed to 0.05. 0.05. The previous was 0.5. This one is again lesser 0.05. 0.05 and with iteration value that is 3. Now let's see the output of this with 3 iteration. So that is again that each and every line is getting converted into Koch. This minute line was not previously converted to Koch curve with second iteration, but with third iteration this small line which is of 0.05 length is also getting converted into Koch curve. This is also getting converted into Koch curve. So that is a snowflake with 3 iterations. Assignment Koch snowflake. If you don't require these 3 lines, if you require only 1 line, so what you are going to do, you are not going to call this Koch curve with 3 lines. You will call it only at once with 1 line. So let's see output of 1 line. So only with red color you are getting only 1 line starting at 0.0. The length is 0.5 and iteration is 0. Let's see output of this, what we will get. So here we are going to get only at 0th position this line, right? at minus 120 position, we are going to get this second line, and at plus 120 position, we are going to make this direction, that is third line. So this is with 0 iteration. If we make here iteration as 1, so output we are going to get that line is divided into 3 equal parts, and the central part getting converted into Koch curve, that is an equilateral triangle without base. So that is somewhat more because here the length is going to differ. So let's see the length for it as 0.15. We will see output again. Yes, so with 0.15 length of each side, we are getting that first iteration with only one line. So this is a Koch curve of single line. It's converted that central part of line into Koch curve. Again, if you want to make second iteration for this line, the length was getting changed from 0.15 to 0.05. Second iteration is the output. Iteration second. So with second iteration, let's see the output. Save it. So it is somewhat changing. So change the length. .05 is the length. So with 0.05 length, we are getting here second iteration. So this line also now getting converted into Koch curve. This line is also getting into Koch curve, and so on. And let's see again with the third iteration, single line with the third iteration. So that is again we require to change the length. Yes. So with length applied to 0.02, we are getting this snowflake with one set. Then again with second calling function, we are getting this side. Third calling function, we are getting this side. For this, we require here, it is at minus 120 because it is making negative angle. So minus 120, and this one with positive 120. So that's why with plus 120 point. So that is what the first single line calling 3 times. We need to change the length. Position is simple 0.0. Next position we are having, that is minus 20. The equilateral triangle second line, that is this line. This line we are going to get here, that is with minus 20. And again this line is getting converted into this, that is with plus 120. So that are the positions we require to remember with 0.0, minus 120.0 and plus 120.0. The lengths are 0.5, 0.15 and 0.05 for 3 iteration for 3 equilateral triangles. Now let's see the third important function remaining, that is draw Koch. So draw Koch is the function which is a recursive function because we are going to call same function inside that function itself. So previous value of x and y we are going to set here to minus 0.7 and 0.5, that is fixed. We are not giving any input to this Koch curve that it will get start from this point or that. So it will get calculated from this xy value itself first. The parameterized draw Koch function, first parameter is dir, direction, which is of float data type, graphics library float data type. Second parameter is length. Third parameter is iteration. Now this whatever direction we are going to get, minus 120 plus 120, that will get converted into radian by applying this formula of multiply with pi and divide by 180. So that is the formula for converting that angle into radian. So that is your dir, which is converted to radian, which is with GL double. From float it will get converted to GL double. Then the new x and new y from the first point, that is the old point. We are going to calculate the rest of the points, so that we are going to form that all other lengths, all other points of your Koch curve. So old x, old y, you are going to add the other points by multiplying length into cos of direction rad, length into sine of direction radian, whatever the angle we are going to set here. So that will calculate the next point of your Koch curve and so on. If iteration is 0, the old x will simply get with new x, new y, and it will get interchanged. So first point and second point we are going to calculate, that is a straight line if iteration is 0. Else iteration will get reduced to minus minus, and we will convert that single line into four sides. So draw Koch, we are going to call again this function recursively itself with plus 60 angle addition. So this is here the central part is getting elevated upside with plus 60 angle. Second line after that it will get elevated to downwards, that is minus 120, and again this one is with plus 60. So you can see it here how we are going to call it. This is our line calculated, then it is converted into three equal lines. This from this part it will get elevated with the angle of plus 60. So this is plus 60, right? So this is first direction change with plus 60. Next part of line from next point, it will get changed to 120, that is minus equal to 120. So it is coming downwards with minus 120 degree. So this is with minus 120 degree. And next we are again going to call draw Koch curve recursively with plus 60 point here. This is with plus 60. So that will left again that remaining part of the line by 60 degree plus 60 degree. So when you are going this anti-clockwise, it is considered as plus 60, down it is minus 120, and that will give you this line. So that is you are getting with the first iteration, and again if you call it again, this will get converted to this, right? And you are going to get Koch curve here. Again this line length is getting converted, you are getting draw Koch curve here. Again this one you are getting converted, and this part also getting converted with second iteration, and so on. With each and every length you are set it will get converted. So that is what we are having, the Koch curve explanation, the smallest function, smallest assignment from all your computer graphics assignment, that is Koch curve. Okay, so I think we are remaining with only 4 minutes now. So this is your Koch curve assignment. Now we will see somewhat advanced assignment, that is 3D cube rotation, where we are going to use some kind of animation. And lastly, animation assignment. Animation assignment, we are having 3 programs. We will just see the execution of it. Many times we are going to keep that animation assignment as a study part. And those who are well and understand that program and can able to explain that program, they can opt for that assignment in the practical sessions also. But I don't think we are having any practical examination this time. But still you can, if you have resources, just execute these all assignments and submit your executed assignment with proper screenshots and all that to my email ID. So this is for first session, Koch curve, and it's all variations with the program. And out. Thank you.